Hey everyone, next subject is DBMS. For DBMS, I will follow both GATE CS and GATE DA syllabus. So in GATE syllabus, there is ER model, relational algebra, tuple calculus, SQL, integrity constraint, normal form, file organization, indexing such as B and B plus trees, transaction and concurrency control. In GATE DA, with all these, there is data warehouse modeling. Okay. So the full DBMS syllabus I divided into some chapters. Chapter 1 is Introduction to DBMS and ER Model. Chapter 2 Functional Dependency and Normalization. Chapter 3 SQL. Chapter 4 Relational Model. Chapter 5 Transaction and Concurrency Control. Chapter 6 File Organization. Chapter 7 is Data Warehouse. So we'll start with Chapter 1, that is Introduction to DBMS and ER Model. Now what is data? Data is a raw fact or figure. We can say the known raw fact of an entity is called as data. Next, record. Collection of interrelated data called as record. Suppose for a person, its name, its salary, its ID, all these are interrelated data. When we are interrelating, that's called as a record. Or simply you can say record is a row, where for a person X we are keeping all the information. Then what is database? Collection of record called as database. In one record we are keeping one person data. In multiple record we are keeping multiple person data. So like there are multiple records, whole total called as database. Now what is DBMS? How can handle the database that called as DBMS? How can create, how can manipulate, how can delete the database? That's all about DBMS. Now definition of DBMS. DBMS is a collection of interrelated data and a set of programs to access those data. So DBMS is a collection of interrelated data. Interrelated data means it's about database, and how can access the database, it's all about DBMS. The collection of data referred as database, so that contains some informations relevant to an enterprises. Like for university, it contains all the data about the university. Suppose a hospital, it contains all the data about the hospital. So the primary goal of DBMS is how we can access the data from the database convenient and efficient. How can store, how can retrieve information from the database more easy way. Next, application of database system. It have applications in every field, like in enterprises, sale, accounting, HR, manufacturing, online retail, for everything we use. In case of banking and finance, for maintaining the banking, credit card transaction, finance, loans, all these we use. Next, in universities, for track of students, instructor, for all the grade, admission fee, for keeping track all these information we use the database. So airline is the first to use database in geographical distributed manner. Next, telecommunication, to keep track of the records, postpaid bill, prepaid bill, for maintaining balance, all these we use database. So database we use everywhere. In every field we need the database and DBMS to manage that database. Next, data abstraction. There are mainly three abstractions: physical level, logical level, view level. Physical level is the lower level, so it describes how we can store the data, how physically it will be stored. That's all about physical level. The physical level describe complex low level data structure in detail. Next is logical level. Logical level describe what data will be stored and how they are related. So the next higher level of abstraction is logical level, that describe what data are stored in database and what relationships exist among those data. It describes entire database in terms of small number of simple structure. So that entire database, that is too complex, that we can divide into small simple structure, and implementation of this simple structure may have complex physical level. Okay, and when someone is using that database, they don't need to aware of the the physical level. They can just use the logical level. So that's called as physical data independence. If someone is using some data, they just know the logical level without aware of the physical level, how exactly data stored. They are just using it without knowing how it exactly stored. That's called as physical data independence. Next is view level. The highest level of abstraction describe the view level. There can be multiple view for the same database. Okay, so there are three levels of abstraction: physical level, logical level, view level. Physical level is the lower level that describe how data will be actually stored. Logical level is the next higher level, or you can say intermediate level. So that's say about what data will be stored and what relation exists between this data. Next is view level. So how it will be viewed. Okay, how system can view it. There can be multiple view for the same database. So this is the diagram. Lowest level is physical level, then is logical level, next is view level. There can be multiple view like view 1, view 2, view n for the same database. Like same database, one can access through SQL, one can access through different query language. So there can be multiple view for the same database. Physical level is the lowest level, next is logical level, next is view level. In today's lecture, I discussed the syllabus with introduction to database like what is data, what is record, what is database, what is DBMS, and data abstraction. In next lecture, I will discuss instances and schema. If today's lecture is helpful for you, please like, share and subscribe. Thank you. Bye-bye.